Hi, I'm Dane Calkins of Legacy Woodworking Machinery. I appreciate your interest in the four-poster bed. This for me has been a project that I've actually been quite proud of. It's very much a turn piece, as you can see, what you would do on a lathe. However, the truth is I've never picked up a gouge in my life, and I don't even own a lathe, never even turned one on. So I'm pretty proud that I was able to do this on the Legacy Ornamental Mill. It was actually a gift for a daughter and son-in-law who recently got married. I'm excited that they're going to have it in their family for, I believe, years to come, and something that they'll be very proud of. Now, before we get started, let me show you just a couple of little details here. The fact of the matter is I would have never made this bed had I not been able to do these cuts. I'm talking about creating the dado to hold your head and your footboard in, and then 90 degrees, being able to put your sideboards in. Now let me just show you on these turn sections here. You can see how elegant they are. All that is just the profile of a router bed. And you'll see we've used the same, turn the piece around, and then we go into transition into some more router bed profiles here to create the foot on a slight taper. Now the finials here, you'll notice on our videotape, they're actually a separate piece. We created the bed on the 60-inch unit. Now if you have the 80-inch unit, you can create this all in one piece. We've done it in two sections. This you'll see is a separate piece. It is nothing more, again, than various profiles of different router bits.
Before we began milling the posts, we used a 3/4 inch diameter Forstner bit to create a mortise on one end of each of the four posts. This mortise will be used to receive the tenon of the finial that will be milled as a separate piece. By using a set of calipers, we can measure the depth of the mortise. The mortised end of the post will receive the dead center of the tailstock. This step will ensure that the finials and the post are centered to each other. If your system has the linear drive motor, mount the A drive gear to the end of the drive shaft. The .25 gear reduction set is then used to mill a 1/2 inch pitch. The 1¼ surface planing bit is used to mill the stock round. When milling stock round, you will generally get a cleaner cut if the router bit is positioned 1/2 inch off center. If you don't have the linear drive motor, mount the spindle shaft handle to the end of the spindle shaft and use both handles to mill the length of the stock. With the stock milled round, we then mill the turn sections of the post. It may be helpful to review the accompanying plans to see which router bits are used and the location of the cuts. The first cut is made at the foot of the post using the 2-inch triple classic plunge bit. The router is positioned at 1 inch. Use the stops to secure the router into place. As the workpiece is turning, the router is brought in from the side until a bit is centered on the stock. Cut the first post until the proper depth is achieved, and then repeat this cut on the 3 remaining posts. To ensure proper alignment when moving stock in and out, mark the drive center and the corresponding prong of the mounting hub. The next cut uses the 1-inch classic plunge bit. Notice that the position of the bit along the length of the piece slightly overlaps with the previous cut. The top section of the foot is created using the 3/4 inch classic plunge bit. The first cut with the 3/4 inch classic plunge bit is positioned at 3 3/4 of an inch. The second cut is positioned 3/4 of an inch to the tailstock side, or at 4.5 inches. The 2-inch provincial plunge bit is positioned at 10 5/8. You'll want to make this cut on all 4 posts, being sure to align the marked prongs with the marked holes. Notice that the final depth of the cut is approximately 1/8 of an inch from the bottom of the bit. The next cut uses a 3-inch triple classic plunge bit positioned at 20 5/8 inches. Bit number 7503, a 1/4 inch radius point cutting roundover bit, is used to add small details to the top of the provincial plunge cut, as well as the top and bottom of the 3-inch triple classic plunge cut. Once these details have been created on the 4 posts, we are now ready to mill the tapered sections. The diameter of the taper is approximately 3 1/8 inch on the bottom and 2 inches on the top. Adjust the bed so that the tailstock end of the machine is the second hole on the left and the headstock is the 4th hole on the left. This equates to a 4-hole difference overall. Remember that this is the setup for the 60-inch unit. The plunge depth of the surface planing bit is set to the same level as the tip or the point of the 1/4 inch radius point cutting bit. With the final plunge depth set, you'll want to mill the final taper in several passes. The final pass will be the full depth of the plunge, with the router positioned 1/2 inch off center. The top of the tapered section should measure 2 inches in diameter. Sanding mops from Cleanspore Abrasives are an easy solution for touch-up sanding. Their phone number is listed in your packet of shop notes for this project. To receive the side rails of the bed, we set our stops on the x-axis at 12.5 inches and at 18.5 inches. On the y-axis, we set the stops equidistant from 0. This distance corresponds with the width of the side rails. To make the cut, we used a 1/2 inch diameter upcut spiral bit. To ensure the depth of the cut, we started by setting the bit on the material. We then used the calipers measured at 1 inch to set the plunge bar. We're now ready to make the cut. Take note that before milling the mortises and dados, the bed has been set back to level. This hardware is made of 1/8 inch heavy-duty steel and is available from Woodworker's Supply. Their phone number is also listed in your shop notes. You'll need to make small relief cuts to accommodate the male hardware. The male piece mounts onto the end of the bed rail. We used a router with a microfence attachment to assure an accurate cut for the proper width of the recess. The head and footboard will mount to the posts at 90 degrees from the bed rails. For the footboard, we set the stops at 13 1/4 inches and 31 3/4 of an inch. For the headboard, the stops are set at 18 3/4 of an inch and 43 inches. We dry fit the headboard and footboards to the posts and then glued them together. A strap clamp helped to ensure that the pieces were held snugly together.
Now let's take just a moment here and talk about the cap piece that fits on top of the headboard and the footboard. You'll notice it's turned and also tapered. It also has the dado cut into it so that it slips on top of the headboard and the footboard and leads up to the keystone piece, which is a finial that has been turned square and tapered here.
The first 3 turnings use the 1-inch diameter classic plunge bit. Notice that the single cove created by the classic plunge bit is cut slightly deeper than the double cove and single bead. This cut should measure approximately 3/4 of an inch diameter. The section between the 2 coves is slightly tapered as it is milled round. The long tapered section of the crosspiece is achieved by lowering the tailstock. The headstock is positioned at the second hole on the left, or the third hole overall. The tail end of the machine is locked into place at the 7th hole on the left, or the 13th hole overall. Remember that this is the setup for the 60-inch unit. With the bed set back to level, you'll want to mill the dado over the entire length of the piece. Check the thickness of the head and the footboard. With the dado cut into the cross pieces, you can now use the 2-inch diameter triple classic plunge bit to create the end. The final cut is the 1/4-inch radius point cutting bit. We are now ready to mill the center key block, which ties the two cap pieces together. The important part of the key block is to get the proper angle of taper to match up with the cap pieces. The best way to arrive at this angle is to set the bed on a taper and make the surface cuts. After making the cut on each of the two sides, remove the piece from the machine and test it on the head and footboard. You may find that in order to get the proper amount of taper, it will be necessary to make a minor adjustment to the machine. First, remove the cap screws from the rail legs on the tail end of the machine. If you have the floor stand, disconnect the elevation system. This will allow you to adjust the machine to a greater degree of taper. After angle of taper has been achieved, set the bed back to level and surface the front and back sides of the blocks. In order for the block to slip over the panel of the head and footboard, you want to mill a slot into the block. The dimension of this slot is determined by the width of the head and foot panels. Using dial calipers can facilitate this measurement. A 90-degree chamfer bit was used to make a transition from square to round. With these cuts complete, we were able to determine the height of the length of the block. Using a straight cutter, we milled the block not quite all the way through. This allowed us to mill a decorative edge on the front and back face.
Notice that the clean side of the cut occurs when the bit rotates into the stock. Tear out is most likely on the side of the piece that is being undercut by the router bit.
To mill the decorative finial that fits on the top of the block, we determine the diameter by measuring the top of the block. Refer to the project drawings that accompany this video to get the exact bits used to make the finial. Once the profile is cut, mill a tenon on the end to fit into the block. The four finials for the tops of the bedposts are milled using 7 different router bits, for a total of 10 different cuts. Refer to the project drawings for bits and measurements. We started by milling 4 pieces of material down to 2.5 inches diameter. This bit is a 1/4 inch radius point cutting roundover and is used on the bottom of the finial.
Notice that the shoulder of the bit does not cut past the overall diameter of the workpiece.
The 1-inch classic plunge bit is positioned next to it.
Follow the plans to complete the finial. The 2-inch triple classic plunge bit is used to form the bottom profile of the top. This bit is a 1-inch triple classic plunge. Notice that this cut is approximately 1/4 inch wider. The top of the finial is created using the 2-inch provincial plunge bit. It picks up where the 2-inch triple classic plunge bit ended. On the bottom end of the finial, we cut a tenon to mount into the top of the tapered post.
The final cut uses the 1/4 inch radius point cutting bit and is made at the top of the finial. We're now ready to attach the finials to the bedposts.
As you can see, with a few router bits and a little skill on the machine, you'll be able to create what's sure to be a lasting legacy.